Hi, in this video we will see what is an arithmetic mean between the two numbers, and we will see what is the formula for that, and we will do some of the practice problems. And similarly we will see the geometric mean formula for that, practice problem for the geometric mean, harmonic mean, and formula for the harmonic mean, and we'll also see that some practice problems for harmonic mean that will help you to understand all these concepts. Arithmetic mean is a number between any two given numbers. Let's say that numbers are a and b. Then arithmetic mean will be a, that capital A, between a and b, in such a way that the new sequence that we get must be an AP. Okay, so given was that AB was in AP, and we have to find such number A, that must then by putting this A between A and B, then the obtained sequence should be AP. So if this is in AP, then what is the condition for it? So we know that the common difference must be same. That if we take the difference between first two numbers and the last two numbers, then they must be equal, so that must be equal, which makes it a minus a equals to b minus a. So we have to find this a, which gives a plus a equals to a plus b, and from here you can see this is 2a equals to a plus b, and this implies that a equals to a plus b by 2. So if we want to find the arithmetic mean between any two given numbers, then the formula for this is a plus b by 2. For example, let's take the numbers which are 2 and 6. Then what should be here between them to make the all the three numbers to be an AP? So from this formula, that will be equals to a equals to 2 plus 6 over 2, which makes it 8 over 2, which makes it 4. So arithmetic mean between 2 and 6 is 4. Now we want to find the n arithmetic means between the two given numbers. Let's say the given numbers are a and b, and if we put the n arithmetic means between these numbers, then a1, a2, and so on, then by definition that the sequence must be in AP, right? So if that should be an AP, so from here you can see that this is our first, and what is the and this is our n plus 2th term, because there are n plus 2 terms in this sequence, where n are the arithmetic means that we have to obtain, and this is the first term, this is the last term, so n plus 2 terms are here. Then by formula of the AP that you can see from the previous video, and this is a1 plus, here n is n plus 2 minus 1 into d, right? And this is given here, this is what, this is b, and that we have to obtain the d. So this is here a plus n plus 1. Okay, so from here you can see n plus 1 times d, so d is unknown. So from here you can see that d is here is equals to b minus a over n plus 1. Okay, so as we know what is d, then we can obtain the formula for a1, a2, and so on by using the definition of arithmetic progression. So a1 will be equals to what? So a1 here will be equals to a plus d, and that the d is given, which is a plus b minus a over n plus 1, which makes it a into n plus 1 plus b minus a over n plus 1. And if you simplify it, then you can get this na plus b over n plus 1. So by continuing in this fashion, we can get a2 equals to what? A2 is equals to a plus 2b. So which makes it a plus 2 and 2b minus a over n plus 1, and that will gives na minus a plus 2b over n plus 1, and so on. So we get a3. So a3 will be equals to what? So a3 will be equals to a plus 3d, and that will be equals to a plus 3, and that was what? That was b minus a over n plus 1. And by solving this expression we get what? That will be equals to a into n plus 1 plus 3b minus 3a whole fraction will be n plus 1, and that makes it a into n minus 2 plus 3b over n plus 1, and so on. And in the end we get an. So an will be equals to a plus, and this is n plus 1 term, so that's why it will be nd, right? So here that is a plus n, and d is what? D is given b minus a over n plus 1. Okay, so from here you can simplify and can get a n minus n a. Yes, that's a n on that, then plus a plus n b over n plus 1. So here a n will be equals to that a n and n a will be cancelled out, because this term and this term is obtained just by multiplying a to n plus 1. So a n plus a, and this n multiply this b minus a makes it minus na plus nb. So these will be cancelled out, and we get a plus nb over n plus 1. So this is nth arithmetic mean between the two numbers a and b. So here we have our first problem about the arithmetic mean, that says that find an arithmetic mean between the number is 3 500 root and the other number is 5 500 root. So this is our A and this is our B, and we have to find the arithmetic mean, and we are denoting it like AM here, but you can also denote it by A, which will be equals to A plus B by 2. So by plugging the values, we get A is what? This is 3 under root 5 plus B is 5 under root 5 over 2, which makes it 4 under root 5. So this is an answer for this question. So here is another question about the arithmetic mean. It says that find an arithmetic mean between the number, this number is 1 minus x plus x square, and the other number is 1 plus x square for any of x. So let's say we say this is A, this is B, and we have to find the arithmetic mean. So what is the formula for arithmetic mean? That we know that arithmetic mean between any two numbers is A plus B by 2. So by plugging the values, what we get, that will be 1 minus x plus x square, and that will be plus, and here that will be 1 plus x square, and the whole dividing by 2, we get what? That will be 1 minus x plus x square plus 1 plus x square over 2, and what it gives? That gives us to 1 plus 1 equals to 2, and minus x plus x will be cancelled out, and this will be x square plus x square, which is again 2x square over 2, and by simplifying it will be 2 into 1 plus x square over 2, which gives 1 plus x square. Okay, so here it says that find four arithmetic means between the numbers. That number is here is a and the other number is b. So we have to find the four arithmetic means. So it means that n in here is 4 for finding the n arithmetic means, and a is 2 under root, and b is 12 over 2 under root. So we have seen earlier that what was the d. So that was formula was b minus a over n plus 1. If you don't want to do in this way, just by using the direct formula, if you don't want to do, so you can put this four arithmetic means between this, then will be given a1, a2, a3, a4, and here we get 12 over under root 2. So how many terms are here? 6 terms. So it means that it gives a6 equals to 12 over under root 2, and by definition that will be a1 plus 5d equals to 12 under root 2. So if you put like the direct value here, then you will can get the same d as you do by using this whole steps. So it will give 2 under root plus 5d equals to 12 over under root 2. So 5d equals to 12 over under root 2 minus under root 2. So what it gives? That gives 12 minus 2, because 2 under root times 2 under root is 2. 12 minus 2 is 10. 10 over under root 2, which gives td equals to under root 2. Got it? So now you have got the D, then you can put the AIs just simply by adding the IDs. So for one, A1 will be equals to A plus D, and here that will be 2 under root plus under root 2, which makes it 2 under root. So this is the first A1. So next one is A2, which will be equals to A plus 2D. So if you put, then that will give 3 under root 2. A3 will be equals to 4 under root 2. And similarly, A4 will be equals to 4 under root 2. So, and so on. Here, that would not be the 4 under root 2. That will be 5 under root 2. And that b is 6 under root 2, which is actually that 12 over 2 under root, right? So these are the four AIs that we have to find between these two numbers. So here is the problem that says that find n so that a raised to power n plus b raised to power n over a raised to power n minus 1 plus b raised to power n minus 1 may be the arithmetic mean between a and b. So that's given. That is given that a_m between a and b is a_n plus b_n over a_n minus 1 plus b_n minus 1. And what we know from the formula, we know that that must be equals to a plus b over 2, right? So what we get? We get the expression a plus b by 2 equals to a raised to power n plus b raised to power n over a raised to power n minus 1 plus b raised to power n minus 1. And we have to solve this equation to find what is n here. So you can see that if we do the cross multiplication here, then what we get? We get this implies a plus b times a raised to power n minus 1 plus b raised to power n minus 1 equals to a raised to power n plus b raised to power n into 2, right? So here you can see that we can multiply this. So a will multiply with both of them, and then again b will multiply with these both. So what we get? So when a will multiply, we get a raised to power n, and when a multiply with this b raised to power n, so we get a b n minus 1. And similarly, when we multiply b with this a raised to power n minus 1, we get b a raised to power n minus 1 plus b raised to power n, which will be equals to 2a raised to power n plus 2b raised to power n. Okay. So from here we can see that one when this a raised to power n will goes to the other side, then it will make it a raised to power n, because this here this is 2 raised a raised to power n, so 2 a raised to power n minus a raised to power n. So let's write it. Then here we left with a b and b raised to power n minus 1 plus b a raised to power n minus 1, which will make it a raised to power n plus b raised to power n. Okay. So we have to solve it. So what we do? We do all the a powers and to the one side and all the other powers to the other side, and what we get? So let me write this expression again. A b raised to power n minus 1 plus b a raised to power n minus 1 was equals to a raised to power n plus b raised to power n, and we can write this that will be equals to a times b raised to power n minus 1 minus b raised to power n, and on the other side a raised to power n minus b a raised to power n minus 1. And from an exponent rule, which says that a raised to power n is what? This is a times a raised to power n minus 1. We can and similarly for b raised to power n, we can write this thing as it is: a b raised to power n minus 1 minus b times b raised to power n minus 1, and on the other side that will makes it a times a raised to power n minus 1 minus b a raised to power n minus 1. And if we take the common in this side, that is b raised to power n minus 1 is common, then in the bracket we get what? That will be a minus b, right? And on the other side, if we take the common, which is a raised to power n minus 1, then in the bracket we will end up with a minus b. This is another argument. So as we know that a and b are the two different numbers, so they are not equals to 0. So as this is not equals to 0 and this is also not equals to 0, so we can cancel this, and we end up with this expression, that is b raised to power n minus 1 equals to a raised to power n minus 1, which implies that b over a whole raised to power n minus 1 equals to 1. And you know that if some number having a power equals to 1, then it means that that power should be 0. In other words, that 1 can be written as b over a raised to power 0. So bases are equal, then powers must be equal. So by putting them equal, so n minus 1 equals to 0, this implies that n equals to 1. So this is our answer. So now we talk about the geometric mean. The same concept as arithmetic mean that if we have a number that are a and b, then we have to put some number between them so that the obtained sequence must be a geometric progression. So if this obtained sequence is a GP, then it means that the common ratio between these numbers must be equal. And what is the common ratio from the first two numbers? So common ratio of the first two numbers is G over A, and the common ratio of the second two numbers is B over G. And we have to obtain this G. So from here you can see by cross multiplication G square will be equals to AB, and that gives us a solution that will be equals to plus minus under root AB, because the one of the root is AB and root is a square of that will makes it AB, and the other will be negative of that. So these are the two geometric means actually between these two numbers. So let's say we have numbers something like 2 and 6. So what will be the geometric mean between them? So we can obtain by this formula that will be plus minus under root 12, right? Okay, so geometric mean between 2 and 6 will be plus minus under root 12. So similarly, so he asked that and how find the n geometric mean between the given numbers a and b. So if we want to find the n geometric mean, then we have to put them between them. So a1, a2, and so on. A n. This is a capital N we are using here, and this is b. So can you tell me how many numbers are them? So definitely here the numbers are n plus 2. So the n plus 2 term is given, which is b, and the first term is given, which is a. And what we have to find? We have to find the common ratio. So by formula for the geometric progression nth term, that will be equals to a1 r raised to power n plus 1 equals to b, and this is a1 is nothing but a. So by putting that, that will be a r raised to power n, so n plus 1 equals to b, which makes it r equals to b over a whole raised to power 1 over n plus 1. Okay, so now as we know that what is r, so we can find all ai's just by multiplying r raised to power of that. So for the a1, that will be equals to ar, and that will be equals to, because this is the second term actually, so that will be equals to b over a whole raised to power 1 over n plus 1 times a. So similarly, you can find the other ai's. So that will be a2. A2 will be equals to a r square. So which makes it a into b over a whole raised to power 2 over n plus 1. And if we put a3, so that will be equals to a r cube. So which makes it a, and this will be equals to b over a whole raised to power 3 over n plus 1. So what about an? So an will be equals to a r raised to power n, right? So that makes it a into b over a whole raised to power n over n plus 1. So this is a formula for an. Okay, so in this way we can find the n geometric means between any of the two numbers. So here the first question is that find the geometric mean between the numbers. The number is a equals to 4 and b equals to 16. Then we know that the geometric mean is nothing but plus minus under root ab. So by putting that, we get plus minus under root 4 times 16 is 64, which makes it plus minus 8. Thus, from here we can conclude that the answer for this question is plus minus 8. That either it can be 8 or it can be minus 8, and you can verify it easily that if you put 4 and then put 8 and then 16, then by common ratio, what will be that common ratio here? That is 2. Then this is a geometric progression. And what if we put minus 8? Then again this is a geometric progression with the common ratio equals to minus 2. So here r equals to minus 2 and here r equals to 2. So that makes it that there are two geometric means between n and 4 and 16. So next one is that, so this is the same expression as for the given arithmetic mean, but here it says that we have to find the value of n in such a way that this expression is a geometric mean between a and b. So this expression is a raised to power n plus b raised to power n over a raised to power n minus 1 plus b raised to power n minus 1. That should be equals to, so here I put that as a positive geometric mean. So I put in further condition that this is a geometric mean which is positive between a and b. So here that will be a b under root. Okay. So we do the same steps as we did in the previous question for the arithmetic mean. So it is actually ab whole raised to power 1 by 2. So when we multiply this, we get what? On the left side, we get a raised to power n plus b raised to power n. On the left side, that will be equals to a n minus 1 by 2 times b raised to power 1 by 2. Because that when this will multiply with this, then that will increase the half power of a, and then multiply by half of the half power of b. Same for the next term, that will make it a raised to power 1 by 2 times b raised to power n minus 1 by 2. Okay, so we take the terms with the highest power to the next one. So we take this term to here and this term to this way, and what we get? Here we get a raised to power n minus a raised to power n minus 1 by 2 times b raised to power 1 by 2, and that will be equals to a raised to power 1 by 2 times b raised to power n minus 1 by 2 minus b raised to power n. Here you can see that this a raised to power n can be written as a raised to power n minus half times a raised to power half. So let's put this, that will be equal to a raised to power n minus 1 by 2 times a raised to power 1 by 2 minus a raised to power, this will be as it is, and that will be equals to a raised to power 1 by 2 times b raised to power n minus 1 by 2 minus b raised to power 1 by 2 times b raised to power n minus 1 by 2. So from here, if we take the common, then what we get? So we get a raised to power n minus 1 by 2 is common. Then here that will be a raised to power 1 by 2 minus b raised to power 1 by 2 equals to, and the other side we take the common b raised to power n minus 1 by 2, and that gives us that a raised to power 1 by 2 minus b raised to power 1 by 2. So since A and B are the different ones, so that will be non-zero, and also that will be not zero. So that will they will cancel out, and we get a raised to power n minus 1 by 2 equals to b raised to power n minus 1 by 2, which implies that a over b whole raised to power n minus 1 by 2 equals to 1. So same argument work here, that a raised to power a over b raised to power n minus 1 by 2 equals to a over b whole raised to power 0 implies n minus 1 by 2 equals to 0, and this implies n equals to 1 by 2. So this is the required value for n. Now we talk about the harmonic mean, and we know that if A and B are in HP and we put that harmonic mean, let's say this is H between, and we say this is our HP harmonic progression, then then how we can find this H? So if this is an HP, then we know that A and B are non-zero here. Then 1 over A, 1 over H, and 1 over B will be in what? That will be in AP. So if they are in AP, then their common difference must be equal. So by putting the common difference of them equals, we get 1 over H minus 1 over A equals to 1 over B minus 1 over H. And if we simplify it, we get 2 over H equals to 1 over A plus 1 over B, which is equals to A plus B over AB, right? So as they are equal, then H over 2 will be equals to AB over A plus B. And then this 2 will multiply with this B, and we get what? And we get H equals to 2AB over A plus B. So this is the formula for finding the harmonic mean between any of the two numbers. So now the same question here, that how we can find the harmonic means between the two given numbers A and B. So by taking that same procedure, that if we pull out the n harmonic means between A and B, then we get this is an HP, that is an harmonic progression, and the reciprocal of it will be arithmetic progression. So we get A over 1 over H1, 1 over H2, and so on, 1 over Hn, and 1 over B, and that will be in AP. Okay, and with it, how many terms are there? There are terms are n plus 2, right? So here we have seen that the first term is A1 is 1 over A, and an plus 2 is 1 over B, and we have to find that what is the D here. So by formula, yeah, that is an AP, then by formula that will be equals to A1 plus n plus 1 into D equals to 1 over B, and this is 1 over A plus n plus 1 into D. So by taking that simplifications, what we get? We get A, that is equals to 1 over B. So we get n plus 1 n to D equals to 1 over B minus 1 over A, which makes it A minus B over AB, that is n plus 1 over D. So D is equals to what? That is a minus b over ab into n plus 1. So simply by adding this d to a and I times d to a, we can get all hi's from I from 1 to n. We can get all the harmonic means. Here we have a question that says that find n so that this given expression is an harmonic mean between a and b. So if we put this expression equals to harmonic mean between a and b, we get what? We get a this thing a raised to power n plus b raised to power n equals to 2ab over a plus b. Okay, so now by taking the cross multiplication here, we get what? We get a plus b into a raised to power n plus 1 plus b raised to power n plus 1 is equals to 2ab into a raised to power n plus b raised to power n, and that will make it a raised to power n plus 2 plus a b raised to power n plus 1 plus b a raised to power n plus 1 plus b raised to power n plus 2, which is equals to 2a raised to power n plus 1 times b plus 2ab raised to power n plus 1. So if we take this term and this term to other side, we end up with a raised to power n plus 2 plus b raised to power n plus 2 equals to a raised to power n plus 1 times b plus a times b raised to power n plus 1. Now we take the highest power of a to the same side, so we take this term to other side and this side and this term to other side. Okay, so what we get here? So we get a raised to power n plus 2 minus b a raised to power n plus 1 equals to here that will be equals to a b raised to power n plus 1 minus b raised to power n plus 2. So by taking the powers common, so we get a raised to power n plus 1, and inside here that will be a minus b, and here if we take b raised to power n minus 1 plus 1 to be common, and we get a minus b, and since a and b are the distinct numbers, they are non-zero, we can cancel out them and we get a raised to power n plus 1 equals to b raised to power n plus 1, and from here we get a over b whole raised to power n plus 1 equals to 1, and this 1 is equals to a over b whole raised to power 0, and from here we get n plus 1 equals to 0, and we get n equals to minus 1. Okay, so here it says that if we have a G and H to be an arithmetic, geometric and harmonic mean between A and B, then we have to show that G square is equals to the product of arithmetic mean and a harmonic mean between the numbers. Okay, so we know that G is what? G is plus minus under root AB, and what is A? A is a plus b over 2, and h is what? And h is 2ab over a plus b. Okay, so first of all, we take the square of g and we get g square equals to what? That plus minus will cancel out by taking the square, and we end up with ab. And if we take the product of them, then what we get? The product a times h is what? This is a plus b over 2 times 2ab over a plus b, and if we simplify it we end up with ab. So let's say this equation is a star equation and this equation is a double star equation. Then by these two equations comparison we get g square equals to a times h. Okay, so hence show the result. So now we